Hello, everyone. It's great to be here. This is my first time in Moldova. So far, I love it. I came here right away. You guys gave out wine, which is amazing. I could warm up a little bit. So my name is Josip. I work for a company called Sofascore. I just want to see a raise of hands. Who knows what Sofascore is? Okay, some hands are up. For those of you who don't know, it's basically a sports platform. We have a lot of different sports. We track statistics, live score results. We calculate a lot of stuff. You can see some of the screenshots. I put this here just to give you an idea of how much data we have just from these couple of screenshots. These are our monthly numbers. So we have more than 28 million monthly active users, 1.4 petabytes of traffic, 400 billion requests every month, and our peak was 1.6 million requests per second. This is just to give you a rough idea on the system that we have. And this is basically a story of how we went from zero, because we started with nothing. I was the first employee. I'm now the CTO. And I'm going to tell you what problems we encountered, how we solved them, what were our fails. Some of the things will be a bit technical, some will not. Hopefully, you will learn something new today. If not, then you will learn a funny story. So when we started, I was in college, and we really didn't know much about scaling a system. So we had just one server, and when a lot of people came, because in this business, people usually come when there's a big game being played. So a lot of people come all at the same time, and the server would just crash. And we didn't know how to fix it, right? So you try to find out how people usually solve this. And the first answer you see is just put cache on it. And this is actually a really good advice. You just put some cache so that you don't have to fetch the data all the time. And we did this, and we did the simplest way possible. We just put a full page cache on it. And we were storing that in memcache. And this helped. But the problem with the way the cache usually works is you have a lot of requests that come to your servers. If it's in the cache, you return it. If it's not in the cache, you go to the backend server and return it. The problem with this is you get a lot of requests at the same time, and your database will die. It's called the cache stampede problem, because you calculate one request, and then you calculate that same request because it's still not in the cache, and everything breaks. What you want to have is where you have just one request going to the backend server. And this is really difficult to solve, especially like 10 years ago when we first started. It's difficult to solve on the application layer. So what we ended up doing is, since we know what the users want, they always want the games that are being played right now or have been playing for the last 2 hours. So we ended up creating a worker which would just proactively cache everything that's going to be played. And this is a really simple mechanism which you can use if you know what your users will open. And this is something that all of the big companies are doing. So if you use Instagram or Facebook or whatever, they don't calculate the stuff when you request it. It's always pre-calculated. It's always put in the cache up front. And it's called proactive caching. So it's really important to know how your users interact with the app. And now, so we have this system in place where we proactively cache, and it works. But then 15 minutes before a big game is happening, we have a certain number of users online. And in those 15 minutes, the number of users will usually triple or even quadruple. So there's going to be a big strain on the system. And this always happens. So it's always the same thing. And 15 minutes before a really big game called El Clásico, for those of you who don't follow sports, it's when two biggest and most popular teams play against each other. It's Real Madrid versus Barcelona. So 15 minutes before the single biggest match in the whole year, so the biggest moneymaker, 15 minutes before, our server is crashing. It's about to die. The CPU is through the roof. Everything is at the edge of dying. And now, this was before the cloud. So today, you would just spin up new machines, right? But at that point in time, you have 15 minutes. You cannot order and build a new server. You cannot do that. So we were thinking, OK, so it's going to die. That's not a really great thing to have. But we also know that the web server is much, much faster than our backend services. Even though the backend services have cache, they still have to boot the app. They still have to fetch from Memcache and display to the user. It would be great if that single website, so it's a single match, the most popular match, just that single site, if that was static. And then we said, well, I mean, it can be static. You can just go on the website of that most important match. We go File, Save As. You get the HTML. You save it to a file. And then you upload that file via FTP, because we were using FTP at that time. Probably some of you don't know what FTP is if you're a younger generation. So we wrote a rule that said, if you're visiting El Clásico, just return the static file. And it worked. But the problem is we now have a static file, which doesn't change. And the game is live, right? It's changing minute by minute. So we ended up watching the game. And then when a change happened, we would open the file in a text editor. We would change, when somebody scored a goal, we would change from 0 to 1, save it, upload it via FTP to the server, and then everything would work. So that's how we saved it. That's how we scale. Thank you very much. So see you next day. I'm joking, of course. But it is like, that's a story I love to tell because everything is going to die. You have to figure out a solution. And sometimes that solution may not be the best thing, but it will work. And that got me thinking. So like, this is the perfect use case for the cloud, right? At that point, it was 2013, we were not on the cloud. And I convinced the founders that the cloud is the way to go. So you get a spike, you scale up, and then when people leave, you scale down, everything works. The problem is, I did not know how to do that. They asked me, do you know how to do it? Will this work? I was sure. I mean, how hard can it be? You just Google it and figure it out. We were young, we were crazy. Nothing seemed impossible. The only cloud at that time was AWS. So we figured, OK, we're going to go to AWS. We're going to learn how to do this cloud thing. And in that process, I kept thinking about this event that happened, where we were manually editing the file. I wanted to have that, but have it be done automatically. And I found this software. It's called Varnish. If you're going to remember anything from today, that's it. This is the single most important thing that we have. It's a reverse HTTP proxy that caches your content. It's blazingly fast. It's open source. It's free. It's what allows us to have the system that we have. It's by far the most amazing piece of software that we have. So we installed this. And the cool thing it has is it has request coalescing built in. So if you have a lot of users that come at the same time, it will only allow one request to go to the backend. Everything else will get queued. And then when the request is handled, all of the users will receive everything. Works really well. This was the architecture that we then built out. It's fairly simple. So we had an Amazon machine image that had the backend service and Varnish. We had some auto-scaling group. We could get rid of Memcache, so we could simplify the system. Everything was working great. The thing to remember here is your app, your backend app, should be stateless always. Because that's what allows you to scale. If you have state, state is difficult to scale. If you have just your app and your state is somewhere else, then it's easy to scale. We also tried MongoDB. We moved from MySQL to MongoDB because web scale. It worked well for a time, and then it didn't. So we had replication issues. We had data type errors. We couldn't analyze the data, which is crazy because we analyze data for a living. So if you cannot do that, that's kind of not the best thing to do for your business. There was issues with locking in those days. We didn't have foreign keys. It was a complete and utter disaster. And then we said, OK, this is not good for us. We have to change. We started looking into how can we replace MongoDB, which is a NoSQL database, and we found Postgres. And this is something that we use today. And I always get the question, yeah, but you're running a large site. Relational databases cannot do it. Yes, you can. You can do it because this is also an amazing piece of software. Why Postgres? Well, because it's open source, it has advanced SQL capabilities, which is important to us. It has minimal locking. There's this thing called the MVCC, multi-version concurrency control. It can be a talk all unto itself, but basically, you can update and read at the same time. Really cool technology. And it has great performance. How great performance? So on one machine that we have, we can get 1 million queries per second and 90,000 transactions per second on a single machine. And one transaction is actually 5 things that change the state, so 500,000 updates. Works really well. So we said, OK, we're going to switch from MongoDB to Postgres. But in my mind, it felt something like this. So because the app itself is global, we have no time for downtime. It has to be running all the time. So in my mind, when I was thinking, we should change out the most basic building block that we have. We have to switch the database. It felt like changing the wheels while going on a highway. But again, we were young. We were crazy. And we said, like, we're going to do it. How hard can it be? And we did it. Not going to go into how we exactly did it, but it's like you timestamp the data and then just change out parts and then do it incrementally. We lost some stuff that MongoDB is good in, but we gained stability, we gained foreign keys, consistency, and analytical power. And this is something that's really, really important to us. So the message here is to recognize the right tool for the job and change if necessary. Because a lot of times, we as developers, we like to experiment with new stuff, which is fine. We like to try out cool stuff. But sometimes that's not really the way to do it. So you should recognize that you made a mistake and then change to find the technology that best suits your needs. We also added queues. This is also an underrated stuff. So everything that is slow should be queued and done asynchronously. Even if you're using microservices, you can have asynchronous communication. This is really important. It was invented 30 years ago. It works really well. So you should always queue everything that is slow. That will allow you to grow your system to handle much bigger number of users. So this was the system on the cloud. We had an auto-scaling group. So the more users come online, the more the auto-scaling kicks in. But the problem here is the cache gets worse and worse because the cache is built into every machine that scales. So the more you scale, the more requests go to the backend, which is not what you want. So we were thinking about this, and the solution is pretty simple. You just put your caching layer outside of your scaling machines. The thing here is I really have a problem with optimizations. I really want to be as optimal as possible. And here you can see that if you have 2 varnishes, you will have 2 requests to the backend because the caching is separate. And I really wanted to fix this so that it's only 1 request. And to do this, you can do hashing of the URL, do sharding. Your load balancer probably supports it. If not, there are a lot of software that do support sharding of the requests. So basically, for different URLs, you go to the different varnishes, and then you can scale your cache linearly. And that's what we do. That's what allows us to have a really good cache hit rate. You can cache everything, and we do. We actually have a system where there's so much stuff in the cache that when we do database updates, when we shut down the database, nobody knows. So nobody notices that we've shut down the database for 10 minutes because everything that is important is actually in the cache. But cache invalidation is hard. It's really hard. There's this joke. The two most difficult things in computer science, so two most difficult things, cache invalidation, naming things, and off by one errors, right? Cache invalidation is hard. But if you commit to it, you can do it. We built out a library that allows us to build out a graph of dependencies so we know what to purge. It's open source. You can check it out. It's on Sofascore's GitHub. So Cloud was great. Everything was working perfectly, auto-scaling, everything. But the thing is, Cloud costs money. It's a lot of money. If you have Cloud, if you have a big project, you know what I'm talking about. Cloud is really expensive. Now, don't get me wrong. I love the Cloud. It's what allows startups to move really fast and test out things, but the traffic is really expensive. So we got to a point where we were paying more for traffic than for compute, which is crazy. You don't want to be paying more for just the data you push through the pipe than you actually do doing the work that's really important. So since we have our caching layer separate, we said, OK, we're just going to move everything off the cloud. And then the caching layer we're going to move off the cloud, and then it's just going to point to AWS. And this was fairly simple to do because we had the caching layer separate. And we saw a 10x reduction in our monthly bill related to bandwidth usage, which was a lot. And then we said, OK, let's see, what if we move everything off the cloud, which was a crazy idea at the time because everybody was moving on the cloud. We said, let's go back. And we did that. It was actually not that difficult because we weren't coupled to AWS. We just started using Docker and stuff like that. And this is a graph of our infrastructure cost. And it might not seem like a lot, but if you overlay that with the number of users in the green, you can see that our users grew exponentially, where our cost was going down. And that's why we did that. And this is a graph of requests through time. You can see really two big spikes. That's the first half and the second half of a game. And this happens because we send out a lot of push notifications really fast, and all of the sport fanatics always open the app, they click, and they go on the app at the same time. And this looks like a DDoS attack, right? And we were using Cloudflare, and they actually detected this as a DDoS attack. They were blocking our own users. So I had to go to the US, to their office, to talk with them and to explain that this is normal for us. And the engineer told me, oh, yeah, you're triggering the DDoS. I'm just going to write an exception for your site really quickly. So nowadays, there's a rule, if Sofascore, then don't do DDoS, because it will break. If you have a big site, I mean, if you have any project, you have to have monitoring. One of the most important things is application performance monitoring. This is a screenshot from New Relic, but like any software that monitors performance works, this is really cool because you can see the most time-consuming stuff. So not the slowest, but what consumes the most. And once you optimize, you can get really big reductions in latency, and that correlates with price, and everything is faster. Sometimes you cannot optimize, but you can increase cache. What's counterintuitive, if you increase the cache just by a little bit, you can have really big impact on the system. So you should monitor everything, but optimize something, because Premature optimization is the root of all evil. I completely agree with that. Also, one question that I get a lot, since we are not on the cloud, what if you have a really big spike and your system cannot handle the users, which is a legitimate question. So what we actually have is we have dedicated machines, and then we have a system that detects if the load is too high, we spin up virtual machines. They join the cluster, the traffic gets distributed, everything works. But the thing is, we have really big cost savings because of that. Our current cost of everything, so all of the clouds, all of the servers, all of the licenses, everything that we have is 0.7% of revenue. And that's why we do it. There's this thing called physics that dictates how fast the light travels. So if you have your data center in Europe, like we have, users outside of Europe won't get the data as fast as those in Europe will. So I sent out an email to one of our moderators in Australia, and I asked him, can you please record a video of the app so that I can see how fast it is? And he said, yeah, sure, here's the video, the app is great, everything is fast, everything is amazing. And I saw these two images. These are loaders. Honest to God, I did not know that we had loaders in the app because of how fast it is in Europe. And I said, oh my God, this is horrible. But they're used to it. Like guys in Australia, everything is slower for them, so they just think that's normal. So what we ended up doing is moving that cache layer all over the world and doing geo-routing. It's not that difficult to do, but you get really big improvements. So we reduce the latency from half a second to 80 milliseconds, which then means that those users get a really great experience and everything is fast for them. And then you're better than the competition, so everybody wants to use your app. So data centers can burn. Even the cloud ones. This is OVH, this is our provider, and this is an OVH data center burning. Fortunately, it wasn't the one we were using, but it was close. So that got me thinking, you cannot have all of your eggs in one basket. You cannot use just one region, you have to use multiple. So we use three actually. And to do that, we are using Kubernetes. We use them because we can actually, it's data center aware, so we can do cool stuff with it. You get easy deployments, all of the code is the same, it's easy to roll back, it's easy to do upgrades. But doing Kubernetes is hard, especially on bare metal. If you don't have to do it, I would suggest you don't do it. You will probably hear some talks in today or tomorrow about Kubernetes. It's an amazing piece of software. Just know what you are getting into. If you're on the cloud, you probably don't need it. It's really cool to solve some of the use cases. Just be careful. It's tricky. I know we broke the cluster 3 or 4 times in production, so that was fun to do. We also do real-time upgrades, real-time updates, because the app needs to show the scores really fast. We use this software for it. It's open source, it's free, it's basically a pub sub server, so we publish the changes, all of the devices get the response at the same time. Our peak was 800,000 connections on just a couple of machines, so works really, really great if you need to do a pub sub type of thing. We also have one petabyte of data stored that we analyze, and if you're not on the cloud, that's really difficult to do. We do that with ClickHouse, also open source. It's crazy how fast it is. We can analyze 14 billion rows in 2 minutes. 14 billion. Crazy stuff. So take from home for this is be stateless wherever possible. Know how your users interact with the app, because that enables you to build out a better system. Cache everything. Sometimes people will say, yeah, but I have personalization in the app, I cannot cache it. Yes, you can. We also do personalization. You can do it. If you don't know how, you can grab me later. We can talk about it. Recognize the right tool for the job. Change if necessary. Queue everything that is slow. Monitor everything and optimize something. And last but not least, keep it simple. We are engineers. We like to try out new stuff. But you should always try to keep your system as simple as possible until the last end. Thank you. I don't know if we have time for questions or not.
Kind reminder to the audience, if you have questions, we have a Telegram channel, MDC24. So each speaker that gets on stage, we open the comment section. So if you have a question for the speaker, please leave your comment there, and we're going to read it for you. Actually, awesome. I have a question for you, because I had a neighboring project, allegedly, and we were scripted by an LLM that basically broke our traffic and website and a little bit overloaded. So my question is...
I didn't understand what we...
So a website was scraped by an LLM project for all of the information, all of the data, so it basically overloaded all of the traffic. The question is, does this help prevent something like this?
Yeah, so we get scraped a lot. We have an anti-scraping system built in on top of ClickHouse, where we analyze a lot of data. But if it's in the cache, it will not overload your systems. And if it's not in the cache, then that's how you can detect a scraper. If somebody hits through the cache all the time, you can just ban the IP.